Welcome to CS 1401 video 8.3. This is an optional video in which I explain how I implemented logical expressions and conditional statements in the Prolog programming language. The first example I want to do is that of the weekend day. So you may remember we had a pseudocode algorithm in Java program which told us whether a given day was a weekend day or not. The Prolog program for this is amazingly simple. Here it is in its entirety. What this says is that Saturday is a weekend day or Sunday is a weekend day. If I evaluate the expression weekend day and some value like Saturday, it tries to match it against one of these statements. So if it matches weekend day Saturday, then it's true. Or if it matches weekend day Sunday, then it's true. Or if it doesn't match either of those, then it's going to return false. Next, let's take a look at is even. So that took quite a few lines in Java. Here's the entire program in Prolog in one line. So what this says is that a number is even if, and that's what the colon dash means, if 0 is numerically equal to, and that equal colon equal expression is the Prolog operator for number equality. So if 0 is equal to n, our variable, mod 2, and basically the idea is that if the number is even, then n mod 2 will be 0, the equality will be true, and so is even will be true. And if n mod 2 is not equal to 0, then the number will be odd, and is even will be false. Let's try it out in the Prolog interpreter. So is even of 17 is false, and is even of 9,224 is true. The pseudocode algorithm for is within also results in a relatively simple implementation in Prolog. Here's the entire program. The idea is that is within of the number, the lower bound and upper bound is true if n is greater than or equal to the lower bound and n is less than or equal to the upper bound. You notice that there aren't any explicit ands and ors like we saw in Java, but they're there nonetheless. So that comma after the symbol lower bound, well, that means and. In other words, is within of n lower bound upper bound is true if n is greater than or equal to lower bound and n is less than or equal to upper bound. We've already seen or, even if we didn't notice it. So looking back at our weekend day program, or happens not within a statement, but rather by having multiple statements. So their weekend day is true if it's a Saturday, or it's true if it's a Sunday. Having multiple statements to express or also works for check two tests. Remember that this was a program that checked to see if a number was even or if it was within the lower and upper bounds. So again, we have two statements. Check two tests of n, and regardless of what the upper and lower bounds are, that will be true if n is even. And check two tests with n lower bound and upper bound will also be true if n is within the lower bound and upper bound. And there are no other ways to prove check tests of n lower bound, upper bound true. So if it fails both of those, then check two tests of those values will be false. Here's another example of using multiple statements as ors. And that's our program for giving grades for tests. What I'm going to do is have a statement that says test grade, and then score is a variable. That's the numeric value coming in, as it were. And A is going to be the value of the grade that results. When is A the correct grade for a score? Well, that's true if the score is greater than or equal to 90. Well, it's possible the score was not greater than or equal to 90. So let's check to see if some other cases might also be true. The grade for a particular score should be a B if the score is greater than or equal to 80. Now, we know that it's not greater than or equal to 90 because otherwise we wouldn't have reached this statement, because the statement with score greater or equal to 90 would have already been executed and the program would have returned. We can do the same thing for C and D. And finally, if the score is not greater than or equal to even 60, then no matter what the score is, and that means the underbar there, that matches anything, it's an anonymous variable, then the grade for that test score will be F. And of course, nobody in this class is going to be anywhere close to that, so with any luck, that one is never going to get executed. Finally, let's take a look at our Prolog implementation of month name. Remember that this is the program where, given an integer from 1 to 12, it returns the name of the month. And if the number isn't between 1 and 12, it returns the string or token invalid month. Here, Prolog again is really clear and simple. Basically, we just match. So if the month name is 1, then the second argument will be January. If the month name is 2, the second argument is February, and so forth. So I've loaded the month name program into the Prolog interpreter, and let's try it out. So if I say month name 3, and then M for month, that's a variable, sure enough, March is the name of the month. And if I say month name of 26, well, then I get invalid month. That's a look at implementing these conditional expressions and statements in Prolog. In many ways, it's a lot cleaner than doing it in Java. But of course, if we were going to try to do fancy graphics and a lot of numerical computation, it wouldn't be so easy. Prolog is pretty good at conditionals. Well, that's it for this video, and I'll see you next time.